In section 17.3, we're going to be talking about vector fields. And in this first little video, we're just going to be talking about what I want you to think about graphically when someone says vector field. Vector field technically is a function where you plug in a point and get a vector. We have seen graphs like this before. For example, here's the easiest kind, right? This is a constant vector field. At every single point, we have exactly the same arrow. You might think a flow looks like this. An idealized flow certainly looks like this, right? All the particles, like in a river from above, all seem to be going in the same direction at exactly the same rate. Real flows don't look like this, but I think this is the first easiest example to think about a vector field. It's a plane full of arrows. These are all way too the same, right? We've also seen linear transformations. These are the kind we graphed in chapter 13. Again, at every point, there's an arrow, and the arrow, if you think about it, this looks like flow. And in fact, that's actually one of the main interpretations we want to have a vector field. At each point, we can look at the arrow, and it should be telling me in which direction the particle at that point is traveling, and the length of the arrow should be telling us how fast. This is a linear transformation that works that way. And very often, at least locally, if you don't go too far away, does resemble a flow. The third one we're going to see a lot of are gradient fields. So at every point, we have a gradient vector. This is actually taken from one of our optimization problems. This is a problem where there were two optimal points. It looks to me like there was probably one saddle point and, I don't know, a min, but it really doesn't matter. The idea is at each point we have a vector. It could be a gradient vector. The only other kind of interpretation we'll actually see is where each of these arrows can be a force vector. So instead of actually telling us how fast that particle is moving in which direction, we have a force being actually imposing its will on that point, and the arrow points in the direction of the force, and the length of the vector tells us how strong the force is. Those are the 3 or 4 different ways we want to be thinking about vector fields. But specifically, when someone says vector field, I just want you to think, oh, that's just a plane full of arrows, or it's a room full of arrows, right? If we have 3-dimensional flow.